Hey there, everybody, welcome back. This is math reading 35 or 321. Something like that. Wait, day 5 of lecture notes, I think. We were comparing decimals, that's what we were doing last time. We also talked about comparing fractions. Sometimes in a calculator, you'll see stuff in scientific notation. I don't know if I talked about it, so I want to mention now what it is, what you'll see, and what it means. Some calculators will show something like 8 times 10 negative 03. Others might have an E here. 8E negative 03. These are the points. This is meant to represent an exponent on 10. So positive exponents represent multiplying itself by that many times, you get like 1,000. Negative exponents do something similar, but they flip it over. They do 1/10 times itself. And you get 1/1,000. What this is doing is it effectively takes our 8. It's got an 8 point like that. The negative 03 means go left 3 with the decimal point. And if you need to fill in zeros, do so. Both of these are equal to 0.008. Sometimes the calculator does it even for low values like this. They normally reserve it for like when these numbers are pretty large and they can't put it on the calculator screen. But every once in a while, you see something like this. So if it's got something like 7.52 times 10 to the second, a positive exponent moves it right. And as I was saying up here, a negative exponent moves it left. So if I move this right 2 times, the number of times it says, I would now have 752. I don't think you'll see positive exponents in here. I'm pretty sure you'll only see negative exponents. We could have something like 3.74 times 10 to the negative 4. This means take our 3.74. And this is a negative 4, so we're gonna move left 4. 1, 2, 3, 4. And the actual value of this is 0.000374. Everybody good? And Marty, good?
Yeah.
That's a fairly straightforward topic. We did fraction or decimals to fractions, no. We did fractions to decimals earlier. Let's go the other way. Decimals to fractions. So what do you want to do? Let's say we had 0.5625. Count the total number of decimal places. In this case, we have 4. What I'm gonna do is I'm gonna take it, I'm gonna dump the decimal places, just write 565. I'm gonna write a 1. And I'm gonna use this 4 to tell me myself how many zeros to put after the 1 down here. So this is 5,625 over 10,000. Now this simplifies, they're both multiples of 5 at least. So if I divided 5625 by 5. I get 1125 on top. Looks like this is gonna be able to get smaller again. 10,000 divided by 5 is 2,000. I knew that without any help. They're both divisible by 5 again. So this is now. The top here is 225. 2,000 divided by 5 is 400. We're getting closer. 5 into 225. You can do this on a calculator, speed it up. 45. 45 over 80. And this simplifies down to 9 over 16. You would never look at this and think 9 over 16. Unless you have a good memory and you've seen something like this before. They don't always simplify. Like if we switch 0.39. In fact, you guys write that as a fraction. I did 1, you guys do 1. What should I have?
3900s.
3900s or 39/100, that's right. Straightforward. Alright. Did you guys get? 21 divided by 10,000, yeah. We've got 4 decimal places. Ooh. But that one. It's 3/10. So there's a couple ways to look at it. If the last numbers are zeros, you don't need to worry about them. Don't worry about them, because they're gonna cancel anyways. So this would be like me. If I had chosen to, writing this as 30/100. But this is 3 times 10 over 10 times 10. And the tens will cancel out and we're left with 3/10. Any questions? Let's look at multiplying by powers of 10. Or multiples of 10. So let's say I have 0.00652. And I multiply this by 10,000. All right, this is not a calculator problem. You should be able to do this in your head, and it's really fucking easy. The same way we counted the zeros before, or counted decimal places, we'll count the zeros here. Count the zeros. And move right that many times. So I have 4 zeros here. I will move the decimal point right 4 times. And this ends up being 65.2. You will see questions like this. Especially when we get to chapter 5 with probability, they'll be like, what's the probability of getting ahead 6 times in a row? And then you'll calculate it, and then the next question will be, if we flip a coin 10,000 times. Or do this like 6 sets of flips 10,000 times, how many times can we expect this to happen? You're gonna take the 10,000 and multiply by whatever probability you got. This is an activity you'll see. So let's say we had 0.0179. And it was times 1,000. What should I get? Think it is? Well, I hope it's not, I guess. What should I have? Inmar, you look like you're done. Anyone else get 17.9? Let's see, we've got 3 zeros, we move it 3 times. Looks like 17.9 to me. Not too bad, right? There's one final category that goes well with the decimals, and that's percents. So decimals to percents or vice versa. We'll start off with decimals to percents. 0.0512. Easiest way to think about how to do percent is you're effectively multiplying by 100%. So we're gonna do we got 2 zeros, we'll shift it 2 zeros. And we get 5.12 and we have a percent this time. So 0.0925 is what as a percent? Anyone have an answer?
$9.25.
Did anyone else get that? Percent. Gotta have that percent there. If you don't have the percent there, it's not clear it's percentage. You definitely wanna have the percent there. Now, word of warning with the homework. Sometimes they have the percent symbol there, most of the time it's already listed there, just outside the box, so you don't need to type the percent sign. Every once in a while, they get a wild hair up their ass and they don't have it there and they want you to type the percent sign. So just look for it, pay attention for it. You're gonna, with a lot of this stuff, they will have you do decimals and then it'll be percentages. And it's word problems. It ends up being a lot of word problems, so you really just gotta read it and go slow through it, make sure you understand what it's asking. If it has the percent symbol, like it sometimes it'll be. And they might show it like this. That's a good indicator that they want it as a percent. You can almost skip reading the question if you see the percent symbol at the end. But it's probably better not to, you should read it. So that would be 13.25%. Percents to decimals. Say we've got 72.9%. So to go to a percent, we had to divide or multiply by 100%. To get out of being a percent, we divide by 100%. So multiply by 100% or divide by 100%. The percents cancel out, you've got 72.9 over 100. But if you remember how we were doing, moving the decimal stuff here. To make them into fractions, it goes the other way. We move the decimal right 4 times. And put in 4 zeros. If we have 2 zeros here and we want to get rid of the fraction, we can go left that many times. So this would take the point or 72.9. And we've got 2 zeros here. We move it left twice. Which makes sense, we moved it right twice to make it percent, we move it left twice to make it not a percent. Does anyone want another one of those? Does anyone not want another one of those? Does anyone give a fuck? I'm giving you guys another one. I only did one. Right as a decimal. I have someone on chat. Oh, Bianca's on chat. She said yes. I don't know to which question. I assume it was, I want another. What do you guys get? 0.042. Did anyone else get that? That works. This also works. You're gonna find that having the 0 there is makes it a little clearer and like if you have it near other shit. You won't fuck it up and think they're together. And it's only writing an extra 0 to put it in front, but now you know it's not another number in front. I don't think stack rank or the homework's prepared either way. You guys ready for more? Alright. Let's start review for. Did anyone need that longer? I see pennies moving, let's start again, shit. Alright, that was some basic review for like mathematics in general. That you'll use throughout the entire class. This is focused about stuff that shows up in chapter 3. One concept is exponents. I mentioned them earlier. When we saw the 8, 10 to the -03 and 8 e to the 03. The calculator puts the O there, it's not necessary. So the way exponents work is. Let's say we had 4 times. Let's choose a prime number, let's use a prime number. Let's do 3 times 3 times 3 times 3. Count the number of times they're multiplied together. That is dead red pen. And what do we get? Shit, you're jumping ahead of me, excellent. There's 4,
12.
what?
12.
We're not adding them. So this is called the exponent. And we put it in an elevated position. It's elevated, that is called superscript. When it's floating in the air. And this number here is called the base. And that's the thing, is the base is what is getting repeated. And this thing actually equals what? Equals 81. So you don't always need exponents. Calculators have different things on how they do exponents. I have a button that says X with a 2 above it, I have a button that says X with 3 above it. If I do that button, if I do like hit 5 and then that button, it's gonna give me 5 times 5 and print out 25. This is called a square. That is read as X squared. And if I wanted something to the 3rd power. These are multiplied together, I get 8. Something to the 3rd power is called cubed. And whatever it is, you say that thing gets cubed or that thing gets squared. This is related to the area of a square. Which is why they call it that. Side times side. And cubed is related to the volume of a, guess what? Cube. Like if you picture like a little sugar cube, I know they still make them. You don't see them that often. A die is usually. Dice are generally shaped of a cube. This is side by side by side. S times S times S, so S cubed. That's S squared, and so that's where they get the name for 2 and 3. We don't have 4-dimensional figures. We only have things in 3 dimensions if we don't count time. That's the last one we gave you special name to, is the cube. If you need an exponent higher than that. Some keys you'll see for exponents higher than 2 or 3. Sorry, higher than 3. Some calculators use this thing called a caret. I think it's spelled carrot like the veggie, but I have no fucking idea how it's spelled. On some of them, you might see. Like a Y with an X. Or maybe an X with a Y up top. They all work the same pretty much. If I wanna do 3⁴ like I had up there. I'm gonna do 3 caret 4.
Can you pull the paper up a little bit more? Yes.
Sorry. 3 caret 4, I hit equal. 81. You guys ready for another? This is not overly complicated, I know it's not yet. It's more tedious than anything else, right? Does anyone need a longer? Alright. I do wanna point out there is a. Yeah, it said exponent, sorry. Jesus, was my spelling that bad? Yeah, I guess. My handwriting wasn't great. There is a difference between. -2 squared like that. And -2 squared like that. This one is -2 times -2. Which equals +4. Here, the square is only on the 2. Not the negative. So this is -2 times 2, which is -4. I don't think that's gonna be a big problem for you guys. I can't think of a point where you're gonna see like negative numbers in here. Well, no, there are times where negative numbers come up, but not where I think you're gonna have exponents. Something that goes along with squares and cubes. The reverse of squaring or cubing. Three squared is 9. There's an operation I can show that ends up with 3. And it's that. Which is called the square root. And there's one that does cubing backwards too. It looks the same. But out here, we put a little 3 on the edge. To indicate this is a cube root. If your calculator has a square button or a cube button, it has the square root and cube root button. Oftentimes. As mine is, and you probably can't see it very well. I don't know if I can make the yellow show up well enough to, right above each key is yellow. A yellow text. So above the x cubed. My box for x cubed, right above it in yellow is a little like that. And I can hit shift to access it. And hit that button. And it shows the cube root symbol, and I can put in 27, and it gives me 3. Square root generally square is generally above the square root button. You probably won't do any cube roots, square roots show up left and fucking right. But. You only have to do them a little bit, and then after that, we're gonna let the computer do everything else. But I do want you to know what's happening when we do it. So we're about to talk about some shit you're gonna see in stats class. I think today. Oh, yeah, good day, showing up today. Everyone ready? You guys are getting a jump on lecture. Standard deviation. Or in this case, sample standard deviation. It's a big fucked up formula, and you're not gonna like it. S equals. We're gonna have this. It's gonna have a zigzag E, crazy E looking E. It's gonna say some shit like XI. It's gonna have an X with a bar over it. It's gonna have a square. It's gonna have N minus 1. The X with the bar over it, we actually call it X bar. And this is the mean of our sample. Usually just called sample mean. This is different than a population mean. Let's use green for population. That's not how you spell population. There we go, population mean. Has a different symbol. It looks like a U with a long tail in front of it. This is pronounced mu. Like U with an M. Or if you play Pokemon, Mewtwo. I don't play Pokemon, but I've seen the movie, he shows up in it. I think he shows up in it, I heard the name somewhere. It's actually the Greek letter. Mu, mu. So we will use English letters for samples. And Greek letters for population. Unless they mean something else. Like this crazy E. That is a Greek letter, but it's used for both. This if you use Microsoft Excel, you've seen it there. This is sigma. And it's called summation notation. But what it really means is. Add up the shit that follows. The other characters here. X with an I. The I is in subscript. Exponents are in superscript. When it's written down below, like at a lower level, it's called a subscript. This is the I. Individual data entry. And I think the only thing I haven't said what it is N. N is always, lowercase n is always sample size. Whereas big N, unfortunately, for some reason, we didn't go for a Greek letter for this. Capital N is population size. I wish they had stayed consistent with it. Got 5 minutes, a quick example. Alfredo, how many siblings do you have, brothers and sisters? 2. So the first person has 2. Imar, you also have 2, excellent. Nothing wrong with that. Bianca, Brittany, how many do you have? You're listening online, they like to talk. Holy shit, Bianca's got 6. Not the biggest number I've seen. I've had students answer like fucking 13 before, I'm like. Holy shit. I'm like, was there like quadruplets or anything? And they said no. I'm like, god damn, mama and daddy were busy.
My mom's side of the family, they're like about 13, and then on top
Oh,
of that,
fuck.
my grandma had like 2 miscarriages. That have been,
God damn.
Yeah.
The further back in time you go, the more people had kids because like kids weren't guaranteed to live as long. You lost kids more. Not that many generations back either. Brittany's ignoring me. We got 3 people here. So like here, I would say, if these are my xi's, x1 would be 2, x2 is 2, x3 is 6. So like these are the I and the xi, and it's telling me which entry in the data. That's all the I means. That's pretty funny, Bianca. But it only needs one of them to have an affair, or their family, she said T, I don't know if they meant T's is that the parents had affairs. But that only means mama had an affair, daddy may have been loyal. Probably not, if mama's cheating, daddy's cheating too. Or he's just poor soul. All right, that's it for this, next time, next week. We will actually like work out how you do some of this shit by hand. We might do it today in class and then if that's the case, we won't do it next week. Let me hit stop record. Oh, slang for, okay.